Nearly every explanation of chatbots tells you the same thing. The model has a working memory, the conversation fills it up, and when it is full, things start falling out of the back. It is a tidy picture. It is also wrong, and there is a simple way to prove it. If the model really had a memory, a long conversation would get cheaper as it went, because after the first few messages it would already hold everything you had said. That is not what happens. A long chat gets steadily more expensive right to the end. It gets more expensive because nothing is being remembered. Every time you press send, your entire conversation, every message you wrote, and every reply it gave is packed up and sent again from the beginning, along with a block of instructions you never see. The machine reads all of it as though for the first time, predicts what comes next, and keeps nothing. You are not continuing a conversation. You are buying the whole thing again, from the top, on every message. That is not a limitation somebody is working on fixing. It is the design, and the vendors write it down in one plain sentence. The interface is stateless, which means you always send the full conversation history with every request. Once that lands, the rest stops being mysterious. Why it forgets halfway through. Why it has a personality nobody in the conversation chose. Why it can suddenly search the web when a minute ago it could not. Why the identical question, asked twice, gives you two different answers. Every one of those is the loop around the model. Not one of them is the model itself. So this is not a video about how the thing was trained. It is about that loop and how little of it is intelligence rather than bookkeeping. It starts in 1966 with a program that understood nothing and fooled almost everybody. In 1966, a computer scientist called Joseph Weizenbaum published a paper in a computing journal describing a program he had written on his university's time-sharing system. He named it ELIZA. The version everybody remembers imitated a particular kind of therapist, the sort that turns your own statement back into a question, and it became known as Doctor. The original code was lost for decades, then found again in his own archives, in a folder labeled Computer Conversations, and restored. So we can be exact about the size of the thing. The program itself is 210 lines. The therapist script is a list of 67 keywords. Here is one of them, verbatim. The keyword is remember. It carries a rank of 5, and its rule matches the shape, anything. You remember, anything. The reply splices whatever followed the word remember into a question. Do you often think of that? That is the entire trick, 67 times over. The ranks decide which keyword wins when your sentence has several. Say something with no keyword at all, and it falls back on a stock line. Please go on. There is no understanding anywhere in that. No model of you, no memory of the conversation, no representation of the world. And people talk to it as though there was somebody there. His own secretary had watched him build the thing for months and knew exactly what it was. After a few exchanges with it, she asked him to leave the room. Weizenbaum put his finger on why in that same paper. The human supplies the understanding, he wrote, attributing knowledge, insight, and reasoning to the machine. Those are the speaker's own contribution. That reaction has a name now. It is called the ELIZA effect. It never went away, and it is the reason the rest of this matters. Between ELIZA and the chatbot on your phone sit about 60 years of attempts, and almost every one of them worked the same way underneath. Somebody wrote the rules by hand. 6 years after ELIZA came Perry, which simulated paranoid thinking rather than therapy, and in September 1972 the two programs were connected to each other across the early internet, one at Stanford, the other in Massachusetts, both driven from Los Angeles. An internet standards document written a few months later records the entire conversation. Its author ran something sharper too, giving practicing psychiatrists transcripts and asking which came from a real patient and which from his program. They could not reliably tell. Then came the pattern languages. You wrote a pattern and a reply thousands of times over, with wildcards so that many phrasings collapsed onto one rule. And here is the detail worth keeping. The most famous of them had exactly one tag for remembering, and it remembered exactly one thing, the bot's own previous sentence. One turn of memory, hand-built, because back then memory had to be built. The customer service bots of the 2010s renamed all of this without changing its shape. Google's own documentation still defines an intent as something that categorizes the user's intention for one conversation turn, extracted into values and answered from a reply somebody wrote in advance, which can only ever answer a question somebody anticipated. Step outside the list, and you get the same flat apology forever, and that is why a generation of people learned to type the word agent and wait. Then in 2017, a paper introduced the transformer architecture, and the whole approach inverted. The model is a text predictor, and I want to be precise about how narrow that is. Your text is first broken into tokens, and a token is a chunk of characters, sometimes a whole word, often a fragment of one. Anthropic's glossary puts one token at roughly 3.5 English characters, and that is not a constant. The same company notes a change of tokenizer made identical text produce about 30% more tokens than before. Given a sequence of those tokens, the model produces a probability distribution over what comes next. That is the entire output, not a sentence, not an answer. A ranked list of candidates for the next single token, each with a number attached. Something then picks one, adds it to the sequence, and runs the model again and again, one token at a time, until it produces the token that means stop. That is also why the reply appears on your screen a piece at a time. The provider streams it back as it is generated, and in the raw stream the pieces are not even whole words. One example in the documentation sends the fragment, "Hello friend." You are not watching it type. You are watching the loop run. We built an entire video on how that prediction is learned, so what matters here is only the shape of the thing. The model is a function. Tokens in, one token out. It has no state that survives the call, and no idea that a conversation is happening at all. Everything that makes it feel like a conversation is added by the software wrapped around it. So let us open that up. When you send a message to a chatbot, 3 separate things are packed into one request. First, the system prompt. This is a block of instructions the operator wrote and you did not, setting the personality, the rules, what it will and will not do, often today's date. In the interface, it is a separate top-level field, and the documentation is explicit that there is no system role inside the conversation itself. You never see it, and it is the reason your assistant has a character that neither you nor the model chose. Anthropic publishes the ones behind its own apps, if you ever want to read one. Second, the entire conversation so far. Every message you sent and every reply you got back, in order, each one labeled with who said it. Not a summary, the actual text. Third, your new message, on the end. All of it goes across as a single request. The model reads it from the beginning, produces a reply, and the connection closes. Nothing is kept on the other side. On your next message, the whole bundle is assembled again, one turn longer, and sent from scratch. This is the most useful sentence in this video, and it is a quotation. The message's API is stateless, which means that you always send the full conversational history to the API. That is the vendor's own documentation, and the other major provider says the same in different words. So the conversation is a fiction, maintained entirely by your side of the wire. There is no session on the other end thinking about you between messages. There is a text file that keeps getting longer and a function that keeps getting called. Everything else in this video falls straight out of that. If the whole conversation goes back every turn, then let us do the arithmetic, because this is the part that takes your money. You are billed by the token. Turn 2 pays for turn 1 all over again. Turn 10 pays for the previous 9. Turn 50 is carrying 50 turns of text. Add that up across a whole conversation, and what you have spent does not grow with its length, it grows with the square of its length. That is the cost a working memory would have saved you, and there is no working memory. The providers know it, which is why caching exists specifically for the repeated part. A cache token is billed at 1/10 of the normal input price. But notice what caching does not do. Those tokens still occupy the space. It changes what you pay, not whether they count. because there is a ceiling on how much fits in the envelope at all. It is called the context window, and it is measured in tokens. The newest models publish a limit of 1 million, while cheaper and faster ones sit at 200,000, and the documentation is blunt about what has to fit inside it. Everything in the request counts. The system prompt, every message, every tool result, every image and document, and the tool definitions as well. Overflow that outright, and the request is simply rejected with an error saying the prompt is too long. Long before that, the application starts trimming for you, quietly dropping your oldest turns or replacing them with a summary. Nothing announces it. So when people say it forgot, that is what happened. It did not forget. It was never told. And the vendor has a name for the slower version of the same problem. As the token count grows, accuracy and recall degrade, and they call that context rot. Here is the one that surprises people most. The model cannot do anything. It cannot search the web. It cannot read your file. It cannot send an email or run a line of code. It emits text, and text is all it emits. The documentation says it in one line. The model never executes anything on its own. It emits a structured request. Your code runs the operation, and the result flows back into the conversation. So when a chatbot appears to go and look something up, this is the round trip nobody shows you. The application sends a list of tools along with your message, each described in plain language with the arguments it takes. Instead of answering, the model can stop and say it wants this one with these inputs. There is a stop reason for exactly that moment. It is called a tool call, and then its turn is over. Your code runs the tool. Your code does the search, reads the file, queries the database, then appends the result to the conversation as one more message and calls the model again with everything, including the answer it just fetched. Only now does the reply you actually see get written, and the model never sees your implementation, only the description you gave it and the result you handed back. The same trick explains chatting with your own documents. Nothing is being learned or remembered. The relevant chunks of your files are found by a search, pasted into the request as context, and thrown away afterwards. One last thing this explains. The step that picks the next token off the ranked list does not have to take the top one. It samples. That is deliberate, and it is why the identical question, asked twice, gives you two different answers. So here is the whole machine, in the order it runs. First, there is no memory. The model is a stateless function, and every reply starts from nothing. Second, your side keeps the conversation and resends all of it, every single turn, along with a system prompt you never see. Third, all of that has to fit inside the context window, and when it stops fitting, your oldest turns are what get dropped. Fourth, the reply is generated one token at a time, sampled rather than chosen, which is why it streams and why it varies. Fifth, when it needs the real world, it does not reach out. It asks your code to, and it waits. Now notice what is missing from that list. There is nowhere in it for a working memory to live. The picture almost everyone starts with does not have a slot in the machine. The mental model worth keeping is this. A chatbot is not a mind you are talking to. It is a very good text predictor, called in a loop, wrapped in bookkeeping that you are paying for by the token, every single message. That is worth holding on to, because nearly every frustration people have with these tools is really a frustration with one of those 5 steps. It forgot is step 3. It made that up is steps 1 and 4. It could not check is step 5. 60 years after ELIZA, the machine still understands nothing, and we are still the ones filling in the rest. What changed is that it has become extraordinarily good at giving us something to fill in. For more content, please like and subscribe.